right, you guys, so, okay, watch. Here we go. And Kevin, come sit down. So, we're going to do square root graphs, but before we do square root graphs, let's write these numbers down. Square root of 0, right? Square root of 1, square root of 4, yeah.
Do you have a heater? It's cold.
Do we have what?
Do you have a heater?
Well, I mean, we can try and turn it up. It'll go up 2 degrees. But I'm just going to try it. It'll kick it up 2 degrees, okay? Okay, now. Thank you. So, listen. This is easy, but you got to listen. I put those numbers up because we're going to use those numbers to make this graph. We're not going to use Desmos. We're not going to use these numbers. We're not going to use these numbers because these are ugly numbers. And we want to graph this fast. Square root of 2, ugly number. Square root of 3, ugly number, okay? Square root of 5, ugly number, right? So we're going to do just, you don't need Desmos to graph this. Because the points we're going to use are 0, 0, because the square root of 0 is 0. We're going to use the point 1, 1, because the square root of 1 is 1. We're going to use the point 4, 2, because if I plug in 4, I get 2. Now, the other numbers are there, but they're the decimal equivalent, right? And we're going to graph this point 9, 3, because the square root of 9 is 3. 2, 3, 4, 5, 6, 7, 8, 9, 3. And we're just going to connect the dots. Those are the numbers we like, because those are numbers that are perfect squares. So if we have to graph this without Desmos, right, without Desmos, we can do it. Square root of 0 is 0, right? Square root of 1 is all the way to 4, right? All the way to 4. Square root of 4 is all the way to 9. The square root of 9 is 3. See how easy that is? Now, all the other numbers are there, but they're just decimal equivalents. You know, so let's just use the easy numbers and connect the dots. And the decimals are there, okay? Now, that's our parent function. And what we want to do today is we're going to move it, we're going to flip it, we're going to do all that fun stuff, but this is our parent function. And then the domain. Domain is how wide or the x values, right? Our domain has to be x is greater than or equal to 0. Starts at 0, and then the graph goes that direction, right? There are no negatives. You can't have a negative square root. So the domain starts here at 0 and goes that way, right? There's nothing over here. You can't have a negative square. So that's my domain. Now the range, reach for your range, starts at a height of 0 and goes up. That's always going to go up, isn't it? Just slowly, but it's always going to go up. It'll eventually get to infinity, but it just takes a while. So my range is going to be y is greater than or equal to 0. Okay, start at a height of 0, and then you go up. There's no graph down here. There's no negatives, and that's it. Thumbs up? That's a lot easier than what we've been doing the last few days. You guys agree with that? Okay, example 2. So in example 2, what do you think we're going to do? Minus 4. What do you think we're going to do? We're going to take this graph and do what with this graph? Down 4, right? So we just take this graph down 4. Okay, and without Desmos, let's do a really easy graph. Right here, right? Over 1, 1. Square root of 1. I'm going to go 4, because square root of 4 is 2. I'm going to go all the way to 8, because square root of 9. Square root of 9 is 3. All the other numbers are there, right? So we just brought our graph down 4, and it should look like this. So it was a translation. We did a vertical translation down 4. Thanks, Emily. Totally right. You said down 4? That's all we did, right? Now the domain didn't change. It just still starts at 0 and goes forward. The domain is still x is greater than or equal to 0. But the range starts at a height of -4 and goes up, right? So the range is y is greater than or equal to -4 because it starts at -4 and goes up. Okay, example 3. Watching?
Yeah.
Why am I doing this? Because I'm stupid? Yeah, sometimes. Why am I doing this? I'm inside the parentheses, and I'm going the opposite direction. Remember that? So that means, and I do stupid things so you won't forget, right? So I'm going to go to the left 3, and down 2. So I'm going to take our graph, and we're going to go to the left 3 and down 2, right? So we're going to go opposite. Remember, it's the opposite. So I'm going to go 3, 2. Let's take this graph and put it right there. Let's take this graph, take the parent function, put it there. 1, 2, 3, 4, 2, 4, 5, 6, 7, 8, 9, 3. Oh, that's a little crooked, but that's basically my graph, okay? I didn't draw that very well, did I? It's okay. Domain. What do you know about domain of this one? What's the domain? Where are we starting at? Are we starting at -3? I'm going that way, right? X is greater than or equal to -3. Our range, what do you know about our range? Start at a height of -2, right? And go up. How am I doing? Okay, this is a lot easier than the last couple of days. You guys agree? Okay, good. You guys ready to turn the page? All right. Now, I'm going to write these numbers down, right? Cube root of 0, 0. Cube root of 1, 1. Cube root of 8 is 2. And I'm not going to use the numbers in between because they're decimal numbers, right? I could, but I don't want to use the decimal numbers. And I'm going to write these numbers down. Cube root of -1 is -1 because you can do a negative. -1 times -1 times -1. You can do that, right? And I'm going to have the cube root of -8 is -2. So the points I want to use, I'm going to use 0, 0, 1, 1. I want to use the point 8, 2. I want to use the point -1, -1, and I want to use the point -8 and -2. So our parent function will look like this. 1, 2, 3, 4, 5, 6, 7, 8, 2, -1, -1, 1, 2, 3, 4, 5, 6, 7, 8. It bends like that, and there's our parent function. And then we're going to move it. Not too hard today. You guys agree? We're just going to move it. So, first of all, let's talk about the domain. How wide is this graph? Good. All real numbers. You guys are saying the same thing. Good. We can say all real numbers, but infinity is correct. So we're going to say the domain is x equals all real numbers. The range. How tall is this graph? All real numbers also, because it's always going up just slowly, right? And it's always going down just slowly. So y equals all real numbers. So, last example. Pretty easy today, huh? All right, not bad. So let's take this graph stupid dance, right? We're going to move it how?
To the left,
And
down 5.
perfect. To the left 3, down 5. So we always do the inside, opposite the inside, okay? And so we do the opposite. So we're going to go left 3, down 5. So when I move this graph, I like to move this point right here. Makes it easier to move that middle point. It's called an inflection point. I don't care if you remember the name, but I like to move that point. So I'm going to take that where it bends. I'll move it left 3 and down 2. And I'm going to go 1, 1. Oh, yeah. Thank you. Yep. Yep. 3. All right. Good thing I have 3 bottles of white out because I make mistakes a lot, don't I? It's all good. Okay, now I'm going to show it to you. So we don't have Desmos. We don't need Desmos. You watching? Are we watching? Over 1. What's the cube root of 1? Now I'm going to go all the way over to 8. Why am I going to go 8? Because there's a cube root 8, right? I don't want to do the numbers in between because there's a bunch of decimals, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 2. And I'll do that in a second. Then here I'm going to go -1, -1, right? And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, -2. Does that make sense? And all the other numbers are going to be there for the decimals. So let's use the easy numbers. And then we'll put that one down, okay? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, super easy domain range. You guys agree? Domain range? Domain is? Yes. Range is? Easy. Okay, that's all I have. So I have a worksheet again today for you for homework. And we've got time to get it done.